2.2 is a 3 joint モデルと7 joint モデルって言ったんだよね。Yes, maybe yes, it's easy to think 3 joint model is the ball joint and elbow joint and also some ball joint. Maybe it is a yes shoulder, elbow, wrist joint. Yes, 3 joint model you can understand easily. But how to realize this model into 7 degree of freedom, 1 degree of freedom joint. Yes, is the next part here. 7 joint. 7 joint means each. Because yes, yeah, this is a ball joint. This is the ball joint. Yes, shoulder, and wrist, and also the hip joint is a ball joint. We can simplify the models in the ball joint. Yes. Shu-san, yes, sir. How many degree of freedom this ball joint has? 3, yes? Which kind of degree of freedom this joint has? 3 rotation. 3 rotation, yes. For example, in this case, up and down and forward and back, and also rotate around this is a 3 degree of freedom. Yes, most important point is how to realize this joint is 1 degree of freedom joint, 3 1 degree of freedom joints. How to realize? Because practically the ball joint driving mechanism we don't have. So we have to realize this ball joint using the rotary actuator. Yes, like the motor. So how to realize the combination of this motor to realize this ball joint is a problem. Okay? And what is the important point of this ball joint? Yes, 3 degree of freedom. What is the important point of 3 degree of freedom joint? Fencer. What is the important point? 3 degree of freedom joint. Nani ga ichiban juyou desu? Most important point. Yes, 3 degree of freedom, it's okay. What is the important point? Rotation angle. Masa. わかりますか？何が重要ですか？ What is important to realize a ball joint? A rotation? 3 kinds of rotation? Yes, of course. And how to connect them together, but yes, the most important point is yes, you said the 13 sets, the 3 degree of freedom. Yes, in this case, up and down and forward and back and also rotate. But the important point is this rotational axis is about これどこあ、まあいいや、これまあいいや、three rotational axis is centralized, closed at one point. Okay, yes, this x-axis, around the x-axis, around the y-axis, around z-axis. Yes, three rotational axis is crossed at one point. Is the most important point about on the ball joint. You can understand maybe. Okay. To realize this in this rotational motor, rotary motor. Yes, this is a rotational axis. Yes, it's easy to think. Yes, 3 degrees of freedom, and each rotation. Yes, we have to realize each rotation, each axis rotation. Yes, we have to put each motor here, maybe each motor here, each motor here. Okay. So the problem is only how to connect it. Okay, how to connect it. Yes, for example, this is a basement. For example, this is a basement connected. So this rotation should be connected to this frame. To this frame, and this output rotation is connected to this frame, and output to here. Okay. So to make it, yes, you can understand. This is connected to this frame is connected to here. And the output shaft is connected to here, and this output shaft is connected to this frame case, and the rotary shaft is the output of this joint. Yes, for example. Okay. So how to express in symbols, using symbols. So for example, yes, it is connected to here. So this is a rotation. Yeah, the rotation. This is connected to here, and this is connected to here, and this is connected to here. Yes? Okay. This is one. あ、ちょっとこれ、もうちょっと離した方がいいですね。こうなっていたら、こうなって、こうなって、こうなってればいいよね。Yes? Okay. So this is this symbol, this 3 degree of freedom, yes, 1 degree of freedom joint is compatible to this ball joint. Okay, you may understand. Very simple, very easy to think. So yes, it is already shown here. It is already shown here. Yes, here. This is humanoid robot arms shoulder joint. already shown here. Yes, 3 industrial robots, 4 industrial robots, なんか representative model. One is なんだっけ? Cylindrical model, spherical model. This is Cartesian model, and the articulated model. And the articulated model, one is a scalar type, one is a parallel link model, and one is a humanoid model. And this is a shoulder joint here, and elbow joint here. Yes. Okay. You may understand about this, and it has already shown here. So the 2.2s. Correct answers. Yes, this is a 3 joint. The another 3 joint is the, for example, in this case here. Yes. まあでエルボージョイントでなんかリストジョイントはなんかこうなって、まあ何でもいいんだけど、こうなってこうなってこうなってこうなってこうで yes hand. Yes, this is a なんだ shoulder joint, elbow joint, wrist joint. Okay, this is the same as this model: shoulder, elbow, wrist. Okay. So it's simple one. So the correct answer is over this. Yes, 1. 2.1 is 3 joint of shoulder, elbow, wrist, and 2.2 7 joint with 1 degree of freedom. Is the correct answer is here. Okay. So the most important point is the 3 rotational axis is crossed at one point. Okay? Crossed at one point. Yes. Here is a crossed at one point. Center of axis, center of rotation is here. Center of rotation is here. Okay? You understand? Yes, that is the main point of this subject. Hi, 3 is easy. Maybe you can understand cylindrical coordinate and polar coordinate and Cartesian coordinate easily. So it is not described here. Okay, questions? Okay, いいですか? Okay. 2 ones misunderstand about this second part, first part. Okay? 2 ones. Okay? You have misunderstood about this practice subject. Okay? You should think. You should think about this subject intention. Okay? Yes. So let's go back to today's part. Yes, today's part is about the yes. Okay. Today's part is about robot mechanism. Yes, total structure of the robot. Yes, I will show something. Firstly, about the joint structure and joint drive type and transmission mechanism and so on. Yes, mainly about the transmission mechanism. Yes, this part. But yes, joint structure, as I said and I have explained here, so the many of the robots consist of the joint and link, serial connection of joint and link. So for the one joint, for example, this part, yes, it can bend around, rotate around this axis. So this link can move forward and back, forward and back. So how to realize this system, this joint? Joint consists of the actuator, sensor, reduction mechanism, transmission mechanism. And actuator is almost the same word as the motor in the electric field. The equipment to transduce energy into the mechanical movement. So the energy, some energy is translated into the mechanical movement. It's actuator. And the sensor is a detection element to realize the sensory function. So the sensor detects the movement, such as the position, speed, and so on, acceleration, and so on. And the reduction mechanism to reduce the speed and amplify the force and torque. Reduce the speed and amplify the force and torque is the reduction mechanism. Okay? Maybe you know the reduction gears. And the transmission mechanism to transmit motion to a distant place. So in this case, the motor is located here, but the movement portion is here. So this motor drives this rotational joint. So some transmission mechanism. This is a generation part, and this is a driven part. So some transmission mechanism is necessary to transmit the movement. Okay. Yes. The joint drive type. Yes, this is a rotation joint. So this arm, this link is moved forward and backward around this axis. So the joint is here. So the joint along this joint, the motor, actuator, and some sensor is connected directly. Is a direct drive type. And in this case, this is a joint axis. Joint rotational axis, and this link is moved up and down, forward and backward. So the rotation is produced around this axis by the motor actuator connected here, and the brake and sensor is here. So the generation is along this axis. So some transmission mechanism is necessary here. Okay. Yes, for example, this is a direct drive manipulator. The link is here, connected to link. Two links is connected. This part and this part. This is a joint, and the joint contains the motor. So this is a direct driving motor joint. Yes, this is a case of indirect drive motor. This is the example of this rotation joint. So this is a scalar type arm. So this axis is rotated by this motor, and this is gear. And some reduction mechanism is here. So this part is moved by this motor. And this part around this axis. So this link is moved here like this. So this joint is moved by this motor, second motor. Second motor is here, and this is connected. So the transmission mechanism is here, and this is the shaft, and this is the transmission mechanism is here, and some reduction mechanism is here, and this output of this reduction mechanism drive this link. Okay. So the generation part, rotation generation part is motor is put on here, but the joint is here. So the separated. So this is an indirect drive type. Okay. Direct drive type and indirect drive type. Direct drive type is joint axis is connected directly to the actuator output axis. And the indirect type joint axis is connected to actuator output axis via the reduction mechanism and transmission mechanism. Okay? And then the merit and drawbacks, advantage and shortcomings is direct drive. Smaller effect of non-linear elements. So only some friction is there. Only some friction is there, so it reduces the non-linear elements. So it is good for the control precisely, controls as you intended. So the non-linear elements is become less. But the drawback, specialized actuator with significant output is required. So all of the load of this joint must be supported by this actuator. So the large amount of output is required for this direct drive motor. Okay, so the motor becomes larger. Joint control is affected largely to dynamic characteristics of arm. And indirect drive. The advantage is common actuator, small power actuator can be used. But the drawback is many nonlinear elements by mechanisms such as low position accuracy due to the clearance gap or energy loss by mechanism. So the transmission cannot transmit 100% power, 100% energy because of some friction or non-linearity. So it makes some energy loss. Okay. So the transmission mechanism, physical amount of transmit motion, in some cases motion, and in some cases forces. Necessity to transmit. Why it is necessary? Transmission mechanism is necessary because the power production place and the power desired place is different. Place is different, so the production and transmitted, transformed, transmitted, transformed, and actuated. Okay, so the generation part and the actuated part is a different places. So the transmission mechanism is required. Simple mechanism is better. Transmission efficiency loss free. So it desirable lossless, minimum loss, and non-linear factor. For example, gap. So it makes the become worse on controllability or stability. Gap. What is gap? In the robot joint, what makes a gap? In the robot joint, what makes a gap? Robot joint. Gap. What is gap on robot joint? Answer.ギャップはだからリダクションメカニズムのギャップなんだけど、リダクションメカニズム。そういう意味でギャップがあるって言ってね、What's the reduction mechanism of gap? あれFor example, you can estimate the most simple reduction mechanism is maybe the reduction gear. Okay, reduction gear. Yes, reduction gear. まあいいや、なんかこうギアありますね、ギアね、ここにもなんかギアこうありますね、ギアね、でなんかここの yes this rotation speed and this rotation speed, yes this is input, for example here is the input, here is the input and here is the output, yes this rotation become half speed, for example this is because t に r となんか r だったな、 yes maybe the speed is reduced to become half, and how about yes なんか you may know the gear の teeth shape, tooth shape. Some of you are mechanical engineer? No? Some of you are mechanical engineer? なんかさ、ここにさ、なんかこう、コンタクトポイント、ギアの tooth, some contact point is here. And other part is here, other gear is here, maybe? Yes. ちょっとなんか良くないけど。Okay? Contact point is here. Yes, it is good. Yes, this is smaller gear and this is larger gear. Smaller gear is move here, and push this. Yes, this is a tooth and this is tooth. They push here. Okay. But if it want to backward, yes, this has some gap. Okay. Not to contact both. Not to contact both. Only one side contacted. Okay. So if it want to reverse movement, it has some gap. It has some gap here. So this gap is not controllable. Make some controllable. Now, if you study about something on the control engineering, maybe you can understand it has some, yes, this is the これなんだっけ、ここなんていうの、ダイス、デスゾーンですか、デスゾーンですね、なんかここのギャップ、デスゾーンのギャップですね。So the input, output, but it cannot work. So this gap makes the controllability. No, so makes both the stability or controllability. Okay. So if you use gear reduction mechanism, it must have some gap. Okay, it makes worse the stability. For example, yes. So next, yes. So this is a problem. How to transmit rotation movement? Yes. Point A is the generation part. Point A is a generation part. Some kind of rotation is generated here. Some kind of rotation is generated here. Point A. Yes, another point B. It should be transmitted. It should be transmitted. How to transmit this rotation to other place is a problem. Evolving movement from a point to other point. Transfer method. What is the transfer method? you should write as much as possible, as many as possible.
But normally it's
Right?
normally it's chair because it can keep.
In any case, it's okay. Parallel shift along rotation axis. Yes, parallelly shifted. Yes, this is a parallelly shifted. And along this axis, along this axis, yes, this is a B point. Is okay.
Okay.
And the perpendicular translation is okay. In any case, it's okay. Yes, you have to transmit somewhere. So how to realize it? You should think as many as possible. Rotation. Rotation, yes, this is a generation. Point A, this rotation is generated. And you have to transmit to other places. Point B, point B, point B. Yes, sometimes it's parallelly shifted. Sometimes it is alongly moved along this axis. And sometimes it is perpendicular axis. So in any case, it's okay. You should think some mechanism to realize transmit the rotation. Yes. Motor generated here. Motor rotation is generated here. How to shift, how to transmit other places. What is the idea to do? Transmission mechanism. Yes, example. Most simple one is the gear train. Gear train, maybe in any kind of gear is okay. So it is rotated here, rotate here, rotate here, and rotate here, and rotate here. So if it has some gear train is around here. So you can transmit, yes, gear. So it can transmit parallelly. Okay, this is one example of the gear train. Yes, you should think other possibility, other idea to transmit. Other idea is, for example, yes, belt and pulley.
Yes.
Yes, belt and pulley is the other idea to transmit. Yes, this is a belt, some belt. Is pulley is here. This is another idea to transmit. Okay.
Yes.
What's more? Yes.
Two wheel, one stick.
Two wheel.
Can I draw it?
Yeah, you can draw. Yes, please. yes, link mechanism. Some mechanical link is connected on here, so it can move. Yes. It is the same as not necessary to wheel, but some link. Link is here, so the まあこうじゃなくていい。まあなんかlink mechanism is here, put on here, so this link can move around here. So the link mechanism is also one solution. Okay. Yes. So we don't have enough time. So for example, this is a small gear and this is a linear gear. What do you call this linear gear? What do you call this linear gear mechanism?
Rack and pinion.
Yes, this is rack, and the small gear is pinion. Okay, rack and pinion. So if you put the small gear here, small gear here, and the small gear here, and put some rack. Rack is a linear gear is here, so you can transmit. Yes, for example, this is go on right and left repeat movement. Okay, so the rack and pinion is also one solution. And this is a belt pulley. Some gum belt is here. So this is toothed belt, toothed pulley is here. And also yes, it is used in the bicycle or motorbike. So what do you call it? これなんて言うんですか？これとこれっていうのは何ですか？このなんかギザとかいうのはこう Yes これとなんかこれはチェーンだよね。チェーンこのなんかこれがここにはまる。Yes cylinder is put here。これなんていうのこれ What is this element? What do you call this mechanical element? これチェーンって何ですか？いや、スプロケットスプロケットって言いません。チェーン、スプロケット。Yes. So the gear train, rack and pinion is here, wire pulley mechanism and synchronous belt. Synchronous belt is toothed belt. Pulley chain sprocket is also band belt pulley. Yes, link mechanism is here. And also some torque tube. Torque tube is only some pipe. Yes, only some pipe. Pipe is yes. You can rotate here, so it can rotate here. Other place, some tube can transmit the movement. And also some more interesting mechanism is like for example, the coil. Coil also can transmit the rotational movement. なんかコイルってバネ、スプリングコイルね。スプリングコイル can also move rotation. Yes. When I was a children, when I was a child, I have some tool, some toy about about fan ってだからファン make window fan ね make window fan or fan ね so it is moved by myself so this is a shaft to make the window and this is a handle まあなんかこうハンドルがあって yes if you rotate this handle this fan is move and make some window. And how to connect it? How to connect it? Yes, this shaft and this shaft. These two shaft is connected by spring. こうなっててさ、こうなってて、スプリングがこうやってつながってたんですね。スプリング。So the spring can transmit the rotational movement. いや、本当言うと、なんかギアトレインがここにこうあって、最後のギアトレインのこことここの間になんかこうシャフトがついてた、そのスプリングがついてたんでね。スプリング。So the gear train, and finally, this spring is connected to this final output to this rotational fan. Okay. So this coil, spring coil, is also can transmit the movement, rotational movement. This is one example. Okay. Yes. Yes. The other motion transmission mechanism, sometimes rotation to rotation, I have explained in the previous page. And rotation translation, rotation and linear movement is come and follower. Yes, come って知ってるんですよね。come. This some kind of shaped plate. Some kind of shaped plate. So if it can rotate, this come and follower. Follower is some idle pulley. So this can, if this come is moved, this shaft can up and down, can move up and down. So this come and follower mechanism makes from the rotational movement to the linear movement. Okay, transmission. Crank mechanism, slider crank. Piston crank is here, for example. Maybe you know about the gasoline engine. Yes, it makes the cylinder explosion, and it makes a movement, rotary movement. So this kind of cylinder piston crank shaft is used to transmission. そうですね。これも形ですね。Okay. And rack pinion, ball screw, belt chain, and transmission. Link mechanism is some kind of link mechanism can make the movement from translate to the translate. Yes. The next part は何だっけ？Basic element of the reduction mechanism, the transmission mechanism. One is a gear, yes, planary gear, spar gear, helical gear, internal gear. This is a sun gear and outer sun gear, and rack. This is a spar bevel gear. Bevel gear is some kind of 日本語では傘、アンブレラという意味ですね。傘歯車ですね。And the helical bevel gear, it can shift. High point gear is a center, rotation center is the same. But the high point gear is this rotation center and this rotation center is shifted. まあネジ、スクリューギア and also worm hoil. Worm hoil, maybe you know it. Worm と worm hoil. Worm hoil 知ってますか？ Worm hoil. ウォームってまあなんかこうシリンダーになんかこう溝がウォームですね。ウォーム。でホイールはまあこうギアホイールですね。ウォームとこれギアですね。ウォームとギア。What is a typical feature of warm gear mechanism? What is a typical feature of worm gear mechanism? So it can, yes,
Leverage.
perpendicular shifted, perpendicular rotational shifted, and what is a more important feature of this worm gear mechanism? 何でしょう?
Big gear can move very slow but with force.
あ、これね、これ、そう、the very large gear ratio.
Oh,
Large gear ratio, so it can move so fast, but it can move so slow. So the large gear ratio. Therefore, large gear ratio. Therefore,
big force.
make big force. Yes. So large ratio. So the speed is reduced so much, so the torque become larger. Yes, this is correct. Therefore,
The force are transferred in one direction.
yes, that's correct. Only from this is input, this is output. But it's difficult to move. This is output and this is input. So the very large gear ratio. So it commonly used only one direction. Okay, this is input part and this is output part.
So worm is input.
No, worm cannot be input. Okay?
So worm is
Input
input.
is input.
Yes, worm is input. So worm is input. Worm is input. This gear is output.
Yes.
So this is a small gear ratio. This is a large gear ratio. So, but it cannot move from here to
Yes.
this worm. Okay,
Yes.
because a large amount of gear ratio. So it works like the brake. Okay. This is one big feature of this worm gear, worm coil. Okay, mechanism. Yes. So the next part is I will show some robot, so motion element in the robot. Yes, this is some gear train is the inside of the robot. Yes, it is simply described in the gear looks like this. Yes, this is a gear and this is another gear in here. So the gear is simply described like this. Okay, this is a tooth is here and tooth is here and this is rotation axis. Yes, okay. Yes, you can see this mechanism afterwards. And also the bevel gear. Yes, I have asked you to search on the South Point mechanism, South Point carrot, several weeks ago. So you have searched on this differential gear mechanism. So in that case, some bevel gear is used in the bevel gears. So for example, this is a robot hand. It has some three tubes. Three tubes is here. Three tubes from this forearm, and each three tubes has some bevel gear. So the most outer one has this bevel gear, and this gear rotate. Yes, the outer one is moved to here, and other two pipes is moved. So this inner pipe is rotate this gear, and this middle pipe is rotate. Middle pipe rotate this gear, and inner pipe rotate. Yes, this outer one is rotate here, and this middle one rotate here. So these two bevel gear is moved. So this part can move right here and rotate. And also this rotation can make the total of the movement can move like this. So you should watch later more in careful. And also rack and pinion mechanism. For example, some rack is here and pinion is here. And if some linear cylinder is moved this rack, it can move. The large amount of rotational force can be produced by this pinion. Okay. And also in some gantry type robot, gantry type moves. A gantry robot is in some kind of factory building. It has some jack and lift. Or is there on the seal. It moves around the seal to move here to jack up or some pick up or large amount of object can move. So to move this sliding mechanism, rack and pinion is used. For example, I will show this small video.
Crane factories, warehouses, and shipyards. And movement of heavy objects within the area covered by the crane's area of operation. Three primary types of cranes are used in industrial settings: bridge cranes, gantry cranes, and jib cranes. Bridge cranes are mounted on parallel rails attached to elevated wall structures. The bridge is a beam that runs between the two rails. A trolley with a hoist mechanism travels back and forth on the bridge. Gantry cranes have a bridge supported by two legs that move along floor-mounted rails or on wheels. As with the bridge crane, a trolley runs back and forth on the bridge. Jib cranes have a jib or a boom that is mounted to a wall or a mast. The jib crane swings in an arc around its pivot, and the trolley runs from it.
はい、こういうやつですね。何番やっていうやつですね。And also in some cases, robot is on the yes. This is a rack, and some pinion is here. Pinion is here to moved by this motor. Okay. So all of the industrial robot is moved linearly. Okay. The next is a linear movement. You know the ball screw mechanism. Ball screw mechanism is also the yes. This is a cup, and the ball is contained in the here, and this is a screw. Screw has some rear actuator to output prismatic movement. Low friction, high precision, high driving speed that within another diameter and long pitch type is usually used for robots. Pitch means here, and the ball is contained on this portion. So it makes some good high precision, high precision. Ball is set into this case in this case. So I will show the small video to explain about its mechanism. Yes. Ball here and this case. So it also has some high reduction ratio. Ball is moved around this portion. Okay, so it makes a high reduction, high ratio. Reduction ratio. Okay. Yes. this is used sometimes directly to this linear joint of the robot. Linear joint of the robot. Linear joint, linear movement of the parallel mechanism sometimes. Yes, and also this is a parallel mechanism because to make the heavy amount of load to handle the heavy amount of load, this linear cylinder is used to move. Yes, sometimes it's a parallelogram mechanism to use for the scalar robot. Parallelogram mechanism is used for this articulated type of manipulator in some cases. So this is a link mechanism to make this movement, and also pantograph. Pantograph is useful to make the movement because the actuator can put on around the base, and the small amount of movement is expanded to here. For example, if the Q is connected, if it is rotated, if it is moved like this, it can move the forward and back, right and left like this. The expansion rate is here and here. Okay. This amount triangle makes the more expansion, amplified distance, is amplified movement. And also if it is connected and if it is moved, this is also this amplified this movement, this small linear movement is moved like this. 違うわ。ここを固定していたら、ここの三角形、here triangle and here triangle。ごめんね。Yes, if it is connected, it is stopped. So if moved right, and this triangle is moved here, so that this triangle is also moved here. Okay? So the pantograph mechanism. What is pantograph? It is originally used for the copying and scaling or some drawing. So it is, it is placed here, and some stylus is moved some figures, and this pencil is draws in some expanded larger size. Okay, so this is used firstly as a copying and scaling line drawing mechanism. And the pantograph is famous in Japan as a railway services. こんだけです。これは別になんか to pick some energy, electrical energy to the railway. So the pantograph is used to keep contact with this line. Okay. And the pantograph is originally used to line drawing and copying. So some shape of the shape. My shape is copied to here. So this shape is placed here. This is a grinder, cutter here. So this is a model to along this. So the user is only follow this shape and it cuts on here. Okay. So ね、このスケールダウンのモデルが you can pick. Okay? So the pantograph mechanism is useful to like this. But the present pantograph mechanism looks like this. This is a commonly industrial robot in recent years. ABB flex picker, and for example, the Panax Genkos robot. Yes, I will show this. ABB's first picker robot is here. Yes, this parallel mechanism is mainly used in such kind of food picking. For example, the pan or some bread or some chocolate or something. Yes, sausage. Yes, to make the package, so it is arranged. This is Panax robot is almost the same. Yes, next is a belt pulley mechanism. Yes. The belt pulley mechanism, there is a tension pulley, idler pulley. What is a tension pulley? Tension pulley is what is tension pulley? Belt pulley, この toothed belt. Tension pulley is necessary. Why it is? What it works? Why it is there? Tension pulley, tension. What is tension? あれ？あの図では yes, belt is here, pulley is here, and the belt is here, and the tension pulley is here. Yes. What this tension pulley doing?
Make the belt fast.
Yes. The belt is here, so this pulley is pushing the belt. Pushing the belt because some amount of tension is necessary. Tension is necessary to make this toothed belt. So it is not to prevent fall down, to prevent the fall down or it loosed. So the tightly fixed to this pulley and belt, this pushing is necessary. So the tension pulley is necessary in this belt pulley mechanism. Okay. Or yes, some it can adjust some position to make the tension firmly. So this belt should be moved along here, or yes, always pushing some amount of force. Okay. Yes, to use the belt pulley mechanism, this kind of tensioner is necessary. And it's also for the chain sprocket mechanism like this. And this is a wire-driven mechanism. Yes, wire-driven mechanism is very useful. Wire is here. This is a pulley wire mechanism is here, and the coil spring. Coil spring is works like the outer tube. I don't remember this.
Control of biomechanical hand
これはいいや。これはなんだ。あ、これはちょっと面白いかもしれない。Yes。ワイヤードリブンロボットです。ワイヤードリブンロボット。スパインモーションデーモンとか言って、スパイナルモーションメカニズムで、The aim of this mechanism is the spinal cord to realize the spinal cord. Spinal cord is here on the back. Spinal cord is yes, and some wire is here.スパインストラクチャーがここにあるんですね。スパインストラクチャーでなんか。なんかこのスパインでワイヤードリブンメカニズムなんですね。If you have some time, you should watch this video. Yeah, several years ago. Yes, this organ player robot is also this hand mechanism, finger mechanism is driven by this wire driven because the motor unit should be located at other places, and this motion is transmitted using this wire torque tube, wire outer tube mechanism. Okay. そんなんですかね。じゃあちょっとthat's all for today. The torque tube is the same as this, and I have shown the Joyan sense mechanism before this class. Yes, some questions. Okay. So maybe today's yes, I will announce this week this industry academia cooperation fair will be held in this science research park. So you should attend. Yes, this Thursday and Friday. So the exhibition will be held at the gymnasium, and some leading robot, Professor Kamata's laboratory, autonomous vehicle from Professor Ogai's group, and also KIT, Kyushu Institute of Technology's laboratory, some robot, and Yasukawa's robot is also shown at the exhibition. Okay, you should visit there. And the lecture, keynote lecture, will be held by Mr. Tsuda. He is the president, COO of Yasukawa Electric Corporation. He will make some opening remarks of this event. So if you can, you should attend this. This is Thursday from 2 o'clock to 3 o'clock p.m. Okay, you should attend here. And some seminar is also there. If you have some time, you should attend, such as a recent topic is robotic technology is here, and the upper arm rehabilitation training robot is presented by the doctor, yes, medical doctor here. So or some other event is there. So if you have some time, you should attend. Okay, and this is a good chance to make the additional score point. Okay, so if you report about the fair, I will and bring to the next class. I will add some score. Okay, score point in addition to this subject. If you have some report about the fair, you should make some separated sheet. Okay, separated sheet about the exhibition fair. And also this is a normal subject. Select one or more transmission mechanism in some system and explain the detail and the movement, operation, and effect, and potency by each mechanism. You have to draw several schematic pictures to explain. And if you have some, if you want to add some related studies and additional description, you can write. And your opinion and feedback about this lesson. Okay? 1, 2, 3. And separated seat, if you want. Okay? In the separated seat, you should make clear what you have watched. The fact part and your opinion part. Yes, as I said, opinion part. You should make clear what you have watched, what you have think, what you think. Okay? You should make clear the fact part and the opinion part. And also, you should, if you make some report on exhibition, you should prepare to make it clear that you have surely attended that conference or lecture. For example, your picture with some robot or something.
Okay.
Okay. Okay. This is a proof.
Yes.
Confidential. Yes. Okay. Yes, that's all for today. No problem. No question. Yes. Thank you for your attention and see you next week.